An introduction to the modulus function. The modulus of a number is just the size of the number or the magnitude of the number without regard to its sign. So for instance, -5 has a modulus of 5. -3.7 has a modulus of 3.7. So we're looking at the number without regard to its sign. The mathematical notation for a modulus is two vertical lines like this. So if I was to put -5 in here, that would equal 5. So what's the number without regard to its sign? And what you find is that the modulus of something is never negative. So let's say if I've got this, what's the modulus of 2 minus 10? Now 2 minus 10 is -8. So without regard to the sign, the answer is just 8, a positive value. Your calculator also has the modulus function here. It's this key. It says ABS, or the absolute value of something. Reset the calculator first. Shift 9 3 equals modulus. So if I put in a negative number here, for example -6, the calculator will return that value but without regard to its sign. So it will just give me 6, a positive value. If I do this calculation here, so what's the modulus of 2 minus 10? It returns +8, positive 8. Here is the graph of y is equal to x. We can see from this graph that y can be positive or negative. The graph of y is equal to the modulus of x can never be negative, meaning that you would never get y values which are negative. So the graph starts from the x-axis and it's above, never below. So for example, let's say that x here is -2. Because y is equal to x, if x is -2, then y is also -2. So when x is -2, so for example this point here, the x-coordinate is -2, the y-coordinate is also the same, it's -2. Let's have a look at this graph now, but from a modulus perspective. So if instead we have y is equal to the modulus of x. So let's start with, let's put some values here. So we've got 1, 2, 3, then -1, -2, -3. One, 2, 3, -1, -2, -3. So when x is equal to -3, the modulus of -3 is +3. So x is -3, y is +3. When x is -2, y is +2. So x is -2, y is +2, x is -1, y is 1, and then 0, 0, and then you've got 1, 1, 2, 2, 3, 3. So what you're seeing this time is this part of the initial graph that we had, so from the graph above, the part that was above the x-axis already is not changed, that's the same. The region that's below the x-axis is reflected in the x-axis to give us this part here. So this is the graph of y is equal to the modulus of x. Now when you're sketching graphs for the modulus function, typically you're not going to plot points. So you're not going to start off with a table of values and then plot points and then draw lines through those points. What you will do is identify any region on the original graph, so the graph without the modulus, and reflect the region that's below the x-axis, reflect that part in the x-axis to get the new graph, the modulus graph. Y is equal to x minus 3. So this is in the form y is equal to mx plus c. So minus 3 is the y-intercept, so let's say minus 3 is here. And then the line y equals x. And it's always a good idea to write down coordinates for the points of intersection between your graph and the coordinate axes. So that's going to be 3. So what does the graph of y is equal to the modulus of x minus 3 look like? Well, the region that was above the x-axis in the original graph, that stays the same. So that part is still the same. Now this region here, which is below the x-axis, will be reflected in the x-axis to give you this. So if that's minus 3 there, reflecting that minus 3 in the x-axis will give you positive 3 here. So this is the graph of y is equal to the modulus of x minus 3. The graph of y is equal to x times x minus 2. When y is 0, we have two roots, x equals 0 and x equals 2. So we know the graph will go through 0, and let's say that's 2 there, 0 and 2. X times x gives you x squared, so the coefficient of x squared is positive. This is a U-shaped curve. So this is the graph of y equals x times x minus 2. So what about the graph of y is equal to the modulus of x times x minus 2? Well, the region that's below the x-axis is reflected. So this part here is reflected to give you this. So now you have the graph of y is equal to x times x minus 2. Let's say that you want to work out the y-coordinate of this point right here. And this point is a maximum on this part of the curve here. If you look at the original graph, this point here would have been down here, the vertex. And that vertex is in between these two roots, 0 and 2. So when x is equal to 1, so if you put 1 into here, you get y is equal to minus 1. So the y-coordinate here is minus 1, which means the y-coordinate after reflecting in the x-axis will be plus 1. So the coordinates for this point, 1, 1. To sketch this graph, what we should do is start off with the graph of y is equal to the modulus of x. And that just gives us that graph. And then we can think, well, that plus 3 is separate to that modulus part here. The plus 3 is a transformation that you're going to apply to this graph. And the transformation is 3 units in the positive y direction. We're going to translate the whole graph by 3 units in the positive y direction. So to get this, that means we need to move the whole graph up by 3 units in the y direction. So if I was to do this, I know that moving up from here to here, that's 3 there. So this is the graph of y is equal to the modulus of x plus 3. In this example, we look at the graph of y is equal to sine x between minus 540 degrees and plus 540 degrees in this range. Now this is a familiar graph. But how does this graph look if you're working out y is equal to the modulus of sine x? Now we know that you cannot have any region below the x-axis. So any region that's below the x-axis is reflected in the x-axis. So that part looks like this, and then you've got this here. That part's below, reflect it, and you've got this. And now I need to get rid of all these parts which are below the x-axis. So this is the graph of y is equal to the modulus of sine x.